Section 7.1, example 5, using the addition method when multiplication of one equation is required. Solve the given system of equations by addition method. So earlier we had it really nicely to where we had just x and negative x, and then we had some other stuff over here, so that when we added them, we ended up with 0 right here. It doesn't look like we could do that here, but what we can do is multiply these equations, so that way when we add them, we're eliminating one of the variables. So let's take a closer look at what we could do. So 5 is not a multiple of 2, nor is it vice versa. But what I could see here is we could turn this really easily into a -3, so that way when we add them together, these two eliminate. So what I really want to do is look at this equation and multiply it by -3. So let's do that. So -3 times equation 2. So -3 times our x minus 2y equals 11 times -3. And let's just distribute this -3 through, and this one here as well. So we have -3x plus 6y is equal to a -33. So we still have to add these two equations together. So this is our equation 2. Let's grab our equation 1. So equation 1 is our 3x plus 5y is equal to a -11. And from here, we could look at just these two equations and add them together and see what we end up with. Could erase this part. So now when we add these two together, remember this is equation 2, this is equation 1. So we're still working with the exact same system of equations. We just had to manipulate it a little bit. So adding the x's together, we get 0. Adding the y's together, we get plus 11y. And adding our constants together, we end up with a negative, what is that, 44. And we could solve for y now. So divide both sides by 11. We get y by itself. Y is equal to a -4. And let's see, we just have our y component so far. We have to plug it into one of the equations to get x. You guys already know how lazy I am, so we're just going to use this equation. So now at this point, there's 3 equations that we could use. We could use this one, we could use this one, or we could use this one that we created. Well, technically this one down here. So we could use any one of these equations here. I personally don't recommend doing this one, because if you did make a mistake somewhere here, you're going to bring that all the way through. You're going to lose a lot more points. But if I noticed that you had used one of these equations here, I could at least catch a mistake. So let's not bring mistakes with us. So let's just use one of the original ones. Again, I'm lazy, so let's try this one. We have x minus 2y is equal to 11. We have y is equal to -4. We're going to substitute it in here for y. So x minus 2 times -4 equals 11. X negative times negative is going to be positive. 2 times 4 is 8. And that should be equal to 11. To get x by itself, we just subtract both sides by 8. Then we have x is equal to 3. So we have our x component here. We have our y component here. So we're pretty much done. All we have to do is tell the world all of this wonderful work we did for this problem. So the solution to our system of equations is that 3, comma, -4. If you have any questions, please feel free to ask. Otherwise, bye.